So for this session, we'll be kind of looking at a multi-agent system in the healthcare domain. Uh, so let's switch to the notebook that we have prepared for today's session. Um, so essentially, in this kind of notebook, we'll be building like multiple agents, and then we will do all the orchestration and showcase how they kind of work. But before that, why we choose like healthcare. In general, healthcare is an important sector where like LLMs and generative AI technologies can bring in a lot of like impact. In general, we can use AI-powered solutions to assist in diagnosis, providing healthcare recommendation, and then offering supports to patient. Um, so in general, for today's kind of live walkthrough, we want to develop an intelligent healthcare platform that streamlines medical service discovery and booking by analyzing hospital data, reviews, and healthcare metric. Basically, this system that we want to build will try to extract and compare key parameters to make like informed decision, and so on. So uh, just kind of briefly going over the core objectives, we want to use NLP based tools to like interpret what user is asking and like process medical terminologies and information. We want to have like context aware responses, and we want to interact with like multiple types of sources, which we can expect in any enterprise setting. And then based on the input query, we want to like provide real-time responses and recommendations and ensure some sort of compliance and ethical AI usage. So more concretely, these are the key milestones that we'll be kind of walking through today. We are building like two agents. The first agent we are building is a hospital comparison agent that will use some sort of like CSV dataset and LangChain's Pandas agent tool. The second agent would be Doctor Slot Booking Agent, which will use SQL plus SQL Toolkit. Uh, so these are just for example purposes. There could be like many different types of tools, many different types of sources that we can integrate with. All of that is kind of easily switchable if like you're working on something different. But I hope like this will communicate just like the end-to-end process of how building these agents look like. And then we'll use the Crew AI orchestrator that'll build for us like a multi-agent system. So based on the input query, like I can decide whether I need like a doctor slot booking agent or do I want a hospital comparison agent, depending on if the user is asking me to book any doctor slots or asking generic information about the hospitals. And then, yeah, we'll also go through live demo of how the execution of these queries look like. And all of that is kind of shown as a unified interface to the end user. So they don't have to worry about like how many agents are there. Like they'll just get the best information possible. And all of the orchestration is happening at the back end. So that is all the context. So without further ado, we can get started with walking through the code a little bit. So this first few steps are generally setting up all the core libraries we need. So LangChain is a really good framework that kind of allows us to build like agentic AI systems. So you've seen like a lot of like LangChain libraries are being used. True AI is again like an orchestrator that can help us consolidate various agents and define workflows between them. We are using SQLite database module because we had mentioned that we'll use this for doctor slot booking agent. And then we have some pandas and CSV tools as well. So yeah, this is just like importing the relevant libraries. For today's kind of demo, although there could be like different types of LLMs you can use, we are gonna be using OpenAI's GPT-4o. In general, there are like some best practices around like API key safety. These should never be in the code, and uh, we should like never deploy a code with the key and the client-side environment like browsers or mobile app. These should be like automatically fetched from some secure location. So these are some of the best practices you can kind of adhere to whenever like you're working with API keys around these LLMs. So this is all just, yeah, setting up the appropriate LLM. We can use like different types of LLMs here, depending on the task. For now, we are not like switching LLMs based on the input query, but that is again like a separate domain where like we can route to appropriate LLMs depending on how heavy or light the user query is, how much processing we need in general. So having set up all the LLM related aspects, now let's walk through building our first agent. So the first agent was hospital recommendation agent, which will be interacting with, let's say, CSV based data. So it doesn't have to have uh, it doesn't have to interact with CSV based data, but this is just for demo purposes. So for now, like we have loaded, let's say some data we had in a CSV format, and then we are just like loading that using pandas. So you can see all the details. There's an ID, hospital name, address, and all the other details about the hospital, things like that. So just a regular data frame. So this gives us all the data, let's say that we might have in our enterprise system. Um, this diagram is a little bit like talking about the process that we'll be kind of going through next. In general, this is how like agentic AI agents would behave. So AI agents, again, just to recap, are LLMs with a set of tools available, and they can like reason about the inputs and the outputs and see whether like we are able to achieve the ultimate objectives that were like present in the user query. So user query would be the input of here. Then we have an LLM, which is GPT-4o in this case. It has access to certain set of tools. In our first AI agent case, it is the Pandas tool, which is getting data from CSV. And then we could also have like multiple tools available, and we can let LLM choose what the best tool for particular action is. But we are not doing that right now. And then we have like a reasoning loop where we'll kind of choose the tool, observe what the input and output are from those tools, and see if we have finally achieved the objective that was set out in the user query. If not, like we'll like repeat this process, and then once we are able to satisfy everything, or there's an error, we'll kind of respond appropriately. So this is how like everything is like architected in an AI agent. And then next we'll see how this kind of translates into code using the various libraries that we had imported previously. So um, just kind of walking through. First is like we are defining the LLM. This is the GPT-4o in this case. There are some parameters here which are kind of good to note. First one is the temperature. So this is a inference time parameter which can range from 0 to 2. Zero means that it'll give you like a very deterministic response. But as it gets bigger, the responses would be more creative, more stochastic. So in this case, we want to be like very deterministic in the responses. So we have set it to 0, and then we have also like capped the maximum output length to 500. And all of this is just like setting up the LLM that we want to use. So now that we have an LLM, we know that like we want to have some sort of like prompt for that kind of LLM. So there is a concept of like user prompt and system prompt. So user prompt is something that is kind of provided by the user itself, but system prompt is like something like a developer could kind of set just to kind of guide the model in behaving a certain way and not being like swayed by whatever the user is kind of inputting. So um, in this case, for let's say hospital recommendation kind of agent that we are kind of building, what we are saying this LLM, how it should behave is that it should act as if it is a highly skilled healthcare agent with expertise in comparing hospitals. It has access to various kind of hospital data through the CSV that we'll be kind of providing, and then it'll evaluate hospitals considering factors such as medical specialties, patient reviews, location, cost, and accessibility features. Um, uh, we are also giving it a certain set of guidelines on how it should be doing the comparison. So there are like certain like dimensions we are providing, condition specific comparison, location, accessibility. These are essentially just like more details in each individual dimension that we want to kind of evaluate against. And then we are also guiding it to look for like specific columns in the data it has access to, uh, just to make sure that the responses are kind of grounded and it doesn't like just deviate too much from what is kind of expected out of this agent. So this kind of system prompt in general helps like ground the responses from the agentic AI agent that like we are building. So that is the fundamental behind the system prompt. Then let's talk about the toolkits. In general, toolkits would allow you to logically group and initialize a set of tools that share particular resource, let's say a database connection or some objects. Uh, they can be used to construct an agent for specific use cases. So uh, uh, for this use case, let's say they are predefined set of tools, for example, databases, JSON objects, or API integration. And these are the tools we were talking about in this diagram, which the LLM has access to so that like it can perform actions, check, verify those actions, and see if it has achieved the ultimate objective, which is kind of set out in the original like user message. Um, in general, yeah, we have to be careful if let's say our agents can use let's say Python under the hood, because like they can generate any code, and if you have given them the permission to like automatically execute, They can also execute some harmful code, which can maybe like delete something, things like that. So there has to be like some guardrails in place when we are kind of building these kind of agents. So that is always like something that you should keep at the back of your mind, have those kind of guardrails in place. So now we are using LangChain's create pandas data frame agent to build an agent, uh, and then you can see like what kind of parameters we are providing. We are passing it an LLM. We are passing it a data frame, which is the data it should be kind of having access to, so that like it can answer the user's query. This is the prompt that we had created previously, the system prompt. This is how it should kind of, uh, let's say, take in the user input and work on the data that is kind of provided to it to kind of finally achieve the objective that is set out in the user prompt. And then there are like other parameters around um, controlling for, let's say, uh, deletion from the databases, which is kind of needed in this case. But like you can like set out these parameters appropriately based on your use case. So these are all the essential things we need to kind of build these agents. So now after everything is kind of compiled, you can see this would be the user prompt that we saw in this diagram, right? So we are just asking it which hospital has good medical imaging, and then after we get the user query, we are using GPT-4o, so it is deciding what tools to use. In this case, it has access to the pandas uh, data frame as its kind of database, so it's essentially kind of going through all the information that is kind of provided in that data frame, and it'll just adhere to like all of these kind of conditions, and ultimately it'll give out an answer that there are several hospitals with good medical imaging, and then providing you a list of the top hospitals that it thinks could be good based on some stats which are available in the data frame. Uh, the same thing could be used for pulling in the data for like specific locations. So this is another like user input query about emergency and finding a phone number for any hospital nearby a certain location. And then you can also ask it about let's say specific care facilities based on the rating. So once it has access to all the data under the hood, like we can do like various type of comparison and ask for like recommendations based on like specific parameters. So this it's nowadays with like these kind of APIs, it's kind of pretty easy to kind of build like just like basic agents. There could be like various complexities which we are not talking about in an enterprise setting to like scale this thing up. But in general, like with a few lines of code, you can build just like a basic um, um, AI agent, and then later in the demo, we'll be kind of walking through some of the logs from these agents to see what they are doing behind the scenes, just so that like we can also visualize that process. Now let's come to the second agent that we wanted to build around like doctor slots. So in this case, like we had mentioned, using SQL based kind of backend. So uh, that's why let's assume for now, let's say data is in CSV, but what we can do is like create a SQLite database using the libraries we had imported, and we'll just like execute various SQL uh, queries to, let's say, create the table and then insert the data that we have in these CSVs. But overall, let's assume that these two tables have these information. The doctor's table would have doctor details like ID, name, specialization, and contact information, and then slots would have something that kind of links to the doctor ID and what kind of slots they're available for. So once, let's say we have created the table, we can take in these kind of data frames and we can push these kind of records to our SQL database. So in this case, basically we are just trying to mimic how we'll see things in an enterprise setting where, let's say, the data is not in like CSV but in some backend kind of database like SQLite. So once we have, let's say, set up our database like this, one thing we want to have in this agent, it is a lever that we can use, is the model memory. So usually we need the model to kind of remember the previous interactions that this user might have done to provide more contextually relevant responses. So that is where the concept of model memory is applicable. There is a class which we can use from OpenAI libraries, which is called conversation buffer memory. So this will store at some capacity, store the past conversation that the user has done with the system, just to make the conversations more fluid. For example, like you might have interacted with ChatGPT. You can ask it one question and then provide more context later on, so it'll still remember like what is that entire conversation is about. So this kind of memory aspect helps with just keeping like a longer memory of like what user was talking about in this particular session. Then again, I think we have talked about the temperature and max token parameters already. So we are setting everything like similar in this case as well. uh, just how we had the pandas tools and toolkit. In this case, we are using SQL database toolkit, which allows like seamless interaction with an SQL database. So instead of like manually writing queries, you can also like automate the process by leveraging LLM powered agent to handle, let's say, query execution, database management, and smart SQL interpretation. So last one is like really good. So like we can just provide it like an English sentence, and then it will be like able to understand how to translate that into an SQL query. So here we are just doing the setup using this library. It should have access to the database. So this is the DB that we had created here. Um, and then we are also giving it the access of LLM. So this is the LLM it'll be using to kind of make sense of the input queries that are kind of coming in. And then once all of that is kind of set up, uh, we are now defining the prompting strategy. So Again, in this case, we are designing a prompt template that defines how the agent should process user queries. So this is like similar to what we had previously in the system prompt, but here like we'll have to provide a little bit more guidance just because we are interacting with the SQL kind of backend. So in general, the SQL guidelines would instruct the AI to use the like operator for flexible name searches, handle case insensitive name matching, and then deleting rows when the user, let's say, request to book a particular slot. So these are the structure that we are kind of providing. As you can see, we are providing these kind of information here. So that will kind of um, just guide the AI agent we are building in the correct direction, just so that like it can take actions. And let's say if someone wants to book a slot, it is able to do the job end to end. So after, let's say we've defined the prompting strategy, this will be like a system prompt. Then our final job is that we want to finally build the SQL agent. So again, the process would be kind of similar. In this case, let's say we are building an agent using the OpenAI tools agent. So again, like we're passing in the SQL tools we have available, the LLM, which is like GPT-4o, and the prompt is the system prompt we have, which is kind of generated from all the restrictions we had provided it. So these are like structured kind of libraries you can use to generate the system prompt ultimately. And then the agent executor that we're defining here would ensure that the AI executes SQL tasks dynamically based on, let's say, what kind of information it is seeing in the action reasoning loop. It can interact with the database toolkit to process query and update records in real time. We can also set up this verbose setting to actually see what is happening under the hood. So, which is kind of very important for debugging. So in general, if we define things in this way, like we don't have to write manual SQL queries. We can automate the slot booking end to end, although like it is doing some dangerous operations. So there has to be some extra validations whenever this is being used in an enterprise setting. Uh, but in general, let's see. So now these are this was like all the code we needed. Like we have LLM, we have the tools and the toolkit, we have the system prompt, and then we define the agent. And then this is the executor we can use to kind of execute like user input prompt, which is kind of collecting the agent and the tools that we had available. So let's say the user input is this. We want to book a certain slot for Dr. Lee. So we can see under the hood, since verbose is true, we can see what actions it is taking. So as you can see, this is the executor chain, which going back, the chain is just this kind of loop. So it'll keep happening until we are able to book a certain slot that the user had mentioned. Or if that is not possible, it'll just like error out. So first of all, it starts like sequentially. It kind of lists all the table, and once the tables are there, it has to see what the schema is like, right? So based on the schema and the tables, it can look at like specific tables and what specific data it has available. So it sees that we have two available tables, doctors and slots, and these are some of the records which are kind of present there. So since the user has said that they want to book a slot for Dr. Lee, again, this could be for example, like it could have like certain format. It could be in let's say uh, uppercase letters, things like that. So that's why we are using, let's say, lowercase and using like to kind of match what kind of doctors this user is referring to. So once that is done, like it'll basically see what doctor kind of match this criteria and what are the slots available. It was finally able to find a doctor named Linda Lee. So the user hadn't provided, let's say, the first name, but it was able to like match it based on the last name. And then it was able to see that there were like certain slots available for this doctor. And then finally it was able to book the 3 p.m. slot. In this case, we had mentioned that it should like delete the slot. That is the sign of booking that slot. So it has also like deleted that, and the user has gotten this response, which is like the final response coming out of these kind of agentic AI system. So then this response could be fed into the UI. On the user side, we also see how that kind of looks like when we have the UI component as well. So in general, as you can see, the user requested a 3 p.m. slot with Dr. Lee. So this AI agent searched for available slots. If that slot was available, it kind of booked that slot, which happened in this case. But let's say if that slot was not available in the tables, for example, it'll throw an alternate response that basically that slot is not available. So yeah, so as you can see, it didn't take just like one step. It kind of looked at what tools it has available. It did like multiple kind of iterations to figure out where exactly that information is present. And then once that information was found, it took the final action to satisfy the user goal that was part of the user query. So this is essentially how end-to-end these kind of system would work. So yeah, just in the interest of time, I think last thing we want to do is also see how we can build like multi-agent system using Crew AI as an orchestrator. So these two agents we saw, they were like working kind of independently, but whenever like we have to deploy things, let's say there could be one agent for doctors slot booking, one agent for hospital recommendation, but all of that would be packaged as just like one system and uh, deployed in production in a unified UI, so that users don't have to worry about like navigating to like different places to get answers to different queries. So that's where like Crew AI is like really useful. So it has like various components. So the first component is like agents, which we kind of already saw. So we have to provide agents which are part of this crew. Um, a crew is essentially a coordinated group of agents organized to achieve some common goal. We can choose the crew or the agents based on their like roles and what like skills we want to have. We can like assign them tasks and manage dependencies to ensure that the tasks are executed in correct order. Tasks are specifically specified duties assigned to specific agents. So, for example, for doctors, slot booking agent, the task will be to book a slot. and it can like differ from like data analysis to controlling, let's say, external systems. Um, Tools is something like we have talked about already. These are the skills or the functions that like agent has access to. And then finally, the process are responsible for orchestrating how tasks are executed by the agent. So let's look at the code of like how we can like wrap everything up into a crew AI based kind of orchestrator. So in general, I think yeah, we are like repeating some of the processes. So here you can see like let's say we are just repeating some process of like loading the data, defining the LLM, and then in this case, what we want to do is we want to wrap the pandas agent that we have and like through AI compatible tool. So it has like various tools kind of available. We can extend this kind of base class to have like certain functionalities. So as you can see, whenever like we are calling run, it'll execute some query on the pandas agent, but this kind of interface is needed to kind of wrap everything up in like true AI compatible tooling. So now we will pass on this tool into a new Crew AI agent that we'll be building. And then that agent will be a part of certain tasks. So for the task, like in this case, like we have just like hard coded a task of like which hospital has a good medical imaging facility, and then we have defined some expected output here. So this is how we wrapped, let's say, hospital comparison agent and Crew AI based kind of fundamentals. We'll repeat the same thing for doctor info agent, right? So this is all that is kind of repeated on what we did earlier. We just have to define a new Crew AI compatible tool, which is the SQL query tool, which is going to be using the SQL agent that we had created, and it'll take in the user query as the input. It'll execute this agent and then provide us the response. Uh, but we do have to create another True AI compatible kind of wrapper for this agent, which will have access to the slots tool. And then we define the task as well. So this is the orchestration part. As you can see, like we had mentioned, a crew will consist of certain number of agents and certain number of tasks. Crew will kind of take care of routing specific queries to appropriate tasks, and then that will appropriately choose what agents it want to use. So that is all kind of handled as part of this kind of framework. So now at this point, this becomes like a multi-agent kind of system. So I can provide different types of queries. Let's say if I provide this, it'll kind of trigger the doctor slots task. If I provide, let's say, this query, which hospital has good medical imaging, it'll trigger the first task, which will use the first agent like this. So this is just to like showcase quickly how we can like gather like multiple agents and have them part of the same system. So as you can see from the output, the first uh, in this case we had hard coded let's say input from the user. So let's say the first agent is executing the first command, and then it is kind of looking everything up, um, and then making sense of all the information that is provided, and kind of reasoning about what hospitals have been tagged as excellent for specific domain, and then based on that, like you can see all the thought process it is kind of going through, and just iterating on its reasoning, and then querying relevant attributes in the database that we had provided. And then based on that, it'll kindly finally come up with like a list of hospitals which kind of satisfy um, the user's query. And we'll kind of repeat the same process for the doctor slot booking tool as well. So all of this just becomes a part of like one system. So uh, that is mostly it for like this notebook, but like I do want to kind of showcase how it'll ultimately look. Let's say this was the code part of it. We can use some other packages to kind of wrap a UI around it. So ultimately, let's say we have few more kind of agents. Let's say we have 4 agents available now. So all of that would be kind of wrapped using like True AI, and then that could be unified as like one packaged experience for the user. And this is how it'll look like. So this unified interface will be able to handle various types of queries. So just as an example, like we have prepared some queries. So let's see how it looks like. So we can ask it like various different types of um, questions which could relate with different types of agents. Um, let's see. So yeah, sometimes there could be some errors if, let's say, a specific query doesn't match with the data we have under the hood. So that is totally fine. In that case, it'll kind of show us that like it is not able to kind of find anything, which is also like a reasonable response. But let's say if some for Dr. Lee, if like some slots are available, then I'll be able to kind of see those as well. And we can also give it some other kind of input. So this one was about like hospital recommendation. This is about slot booking. Then I can also look up like availability of ambulances. And then the last one we have is like something like different. Uh, it is about like um, uh, cancer screening kind of process. So again, like all of these are like widely different. So if we have like specific agents which have access to like specific tools under the hood, we can make it like very relevant, and like the performance would be much more than us trying to use like vanilla LLM, which might have like generic knowledge, but it won't be able to like answer, let's say, queries like this, which are like very enterprise specific.
Want to build an AI agent? If you want to build it now, watch this masterclass linked here. But if you want to build it in class with live guidance, join our free webinar. The link is in the description. See you in class.